Okay, so in the last class we have discussed regarding the 4 different types of overcurrent relays. We started with instantaneous overcurrent relay, then time delayed relay, then we have discussed the inverse time overcurrent relay, and at last we have discussed the inverse definite minimum time overcurrent relay. So, with this background of four different types of overcurrent relay, let us solve few numericals. So, let us consider that there is a figure shown here and it is a single line diagram of a portion of power system. So, the one relay is R is connected on this feeder, and this relay is a IDMT relay having normal inverse characteristic. The setting range of this relay that is relay R, that is 50% to 200% of 1 ampere in steps of 25%. So, here 1 ampere is the relay rated current. The relay has also contained the high set instantaneous unit, and its setting range is from 400% to 2000% of 1 ampere in steps of 100%. The plug setting and the time dial setting of this IDMT relay, that is given as the 100% of 1 ampere and the TDS is 0.5. The setting range of instantaneous high set unit, that is also the set value, that is also 1200%. So, for two different fault cases, say in first case if fault occurs as shown in this figure, and if the magnitude of fault current is 600 ampere, then you need to calculate what is the time of operation of relay. And in second case, when the fault occurs and if its magnitude is 1500 ampere, then also you need to find out what is the time of operation of relay R. So, let us solve this example. So, in this example, as I told you, the relay R is connected across the secondary of CT. This relay is IDMT overcurrent relay. The CT ratio given, that is 100 by 1, and the fault that is going to occur here, and there are two cases. In the first case, the magnitude of fault current, that is given as 600 ampere, and in the second case the magnitude of fault current, that is given as 1500 ampere. So, we need to plug setting of this relay, that is given as 100% of 1 ampere, that is the relay rated current, and its TDS value, that is given as 0.5. The setting range of this relay R, that is from 50% to 200% of 1 ampere, and that is in steps of 25%. The setting range of instantaneous high set unit, that is given as 400% to 2000% of relay rated current, that is 1 ampere, and this is in steps of 100%. So, with this background, let us find out the time of operation of relay. So, in order to find out the time of operation of relay R, we are going to use the formula, that is 0.14 divided by multiple of pickup current raised to 0.02 minus 1 into TDS of the relay R. Now, as TDS of the relay R is given, plug setting of the relay is also given. So, we need to find out the multiple of pickup current. So, to find out the multiple of pickup current, let us consider the case 1, that is say the first case where the current magnitude of fault current, that is 600 ampere. So, for 600 ampere fault current, we know that the multiple of pickup current is given by fault current referred to CT secondary divided by plug setting of relay R. So, if I just find out the value of ampere multiple of pickup current, then fault current is 600 ampere, and when it is referred on CT secondary side, so it is 600 by CT ratio, that is 100, and divide by plug setting of the relay. The plug setting of the relay is given as 100% of 1 ampere, so that is 1 ampere. So, multiple of pickup current, that comes out to be 6. So, with this value, if I put this value here, then we will have 0.14 divided by 6 raised to 0.02 minus 1 into TDS, that is given as 0.5. So, if you solve this, then it comes out to be roughly around 1.9 second. So, that is the time of operation of relay R for the first case when magnitude of fault current, that is 600 ampere. So, that is for first case. Now, let us consider the second case when the magnitude of fault current, that is say 1500 ampere. Now, if I look at the fault current value, obviously we can calculate the value of MP, whatever it comes out. In this case it comes out to be 15, and you can put the value of 15 here and you can calculate the time of operation of relay for second case. However, the setting of instantaneous high set unit, that is also given. So, if I look at this example, the setting of instantaneous high set unit, that is given as 1200%. So, as the setting of instantaneous high set unit, that is given as 1200% of rated current, that is 1 ampere. So, that comes out to be 12. So, if I find out for the magnitude of fault current, that is 1500 ampere, then for 1500 ampere, if I divide it by CT ratio, that is 100 by 1, then this comes out to be 15, and as this 15 is greater than this value, that is instantaneous high set unit. So, there is no need to calculation of time of operation of relay using this formula. So, we can directly say that in when the current, if current exceeds this value 12 multiple of pickup current, then relay operates instantaneously. So, relay operates, that is instantaneously. So, there is no need of any calculation for the second case. We can directly say that as its value 15, that is greater than 12. So, relay operates instantaneously. So, that is the case. So, we have solved both the cases and we can find out the time of operation of relay. Let us also consider the another example in which the similar type of figure is given, where the relay is given, that is known as 51. So, let us also solve this example. Now, what is asked, what is given in this example? There is a relay that is connected in the feeder. The fault current magnitude given, that is 3000 ampere. The CT ratio given, that is 500 by 1. The relay, that is a overcurrent IDMT overcurrent relay. As I told you earlier also, the relay is always denoted by standard number. So, the number given to the overcurrent relay is 51. So, here it is written 51. So, this relay is desired to operate at 400 ampere current. So, 400 ampere is the primary side current. So, equivalently when you transferred with CT ratio 500 by 1. So, on secondary side relay will operate accordingly. This relay is a IDMT overcurrent relay having normal inverse characteristic and its rated current is given as 1 ampere. The plug setting range of this relay is 50% to 200% of 1 ampere in steps of 25%. The overload withstand capacity, that is 20% above the normal current or full load current. The desired operating time of fault current for 3000 ampere fault current magnitude, that is given as 1 second. So, if fault occurs on the feeder with 3000 ampere magnitude, then the relay 51 will operate in 1 second, that is the meaning. The high set instantaneous unit available in the relay 51, that should operate at 6500 ampere, and the setting range of high set instantaneous unit, that is 400% to 2000% of 1 ampere in steps of 100%. So, for this case we need to determine the time dial setting of relay 51, and we need to also find out the what is the setting of instantaneous high set unit, because its setting is not given. What is given is its a value, that is 6500 ampere. Now, let us solve this example. So, to solve this example, let us consider the same data. So, let us assume that the feeder and here the relay 51 is connected. The CT ratio given, that is 500 by 1, and the fault occurs on this feeder. So, and the fault current magnitude that is given as 3000 ampere. The relay 51, the setting range is 50% to 200% of rated current, that is 1 ampere, and this is in steps of 25%. The time dial setting range of this relay, that is 0 to 1 second in steps of 0.05 second. So, this is also given. Then it is also given that the full load current, that means this relay 51 is desired to operate at 400 ampere, that is on primary side. So, 400 ampere we need to consider. It is also mentioned that the relay, this is also capable to take care of 20% overload. So, plug setting of this relay, that is not given. So, we need to find out the plug setting, as well as we need to find out the time dial setting of the relay. What is given is, if fault occurs with a magnitude of 3000 ampere, then this relay 51 will operate in 1 second. So, time of operation of this relay 51, that is also given. So, let us first find out the plug setting of the relay. Now, as I told you earlier, the plug setting of any relay, that depends on the full load current of the feeder that is carried out by the feeder. So, and this is also with allowable percentage of overload. So, the plug setting is, if we wish to decide, then we have to find out what is the full load current it can withstand. So, it is mentioned that it can withstand 400 ampere full load current, plus it can also withstand 20% overload on 400 ampere. So, 20 into 400, that is comes out to be 480. So, the feeder can withstand 480 ampere current on primary side and equivalent current on secondary side. So, if I divide this 480 by CT ratio, that is 500, so that comes out to be roughly around 0.96, or in percentage 96%. This is of relay rated current on secondary side 1 ampere. So, now you can decide the plug setting based on this value. The setting range of this relay is 50% to 200% of 1 ampere in steps of 25. So, above 96%, the next step available, that is 100%. So, we can decide the setting of relay, that is 100% of 1 ampere. So, this is one thing that we can calculate. Now, with this background, let us find out what is the TDS of this relay. So, time of operation of relay, that is given by 0.14 divided by multiple of pickup current raised to 0.02 minus 1 into TDS. Now, for 3000 ampere fault current, the time of operation of relay, that is given as 1 second. So, that is 1.14, and we need to find out the value of TDS. The multiple of pickup current, so multiple of pickup current we can find out as the fault current magnitude is given as 3000 ampere. So, we know that multiple of pickup current is given by fault current referred on CT secondary side. So, 3000 ampere divided by CT secondary side. So, CT ratio, that is 500, and the whole divided by plug setting of the relay, that is 100% of 1 ampere, that is 1. So, we can say that comes out to be 6. So, if I put this value here 6 raised to 0.02 minus 1, so we can easily calculate the value of TDS. If you calculate it, that comes out to be 0.261. Now, as the setting range of this TDS, that is given as 0 to 1 second in steps of 0.05. So, beyond this 0.261, the next available range, that is 0.3. So, we can select the TDS of relay, that is 0.3, that is selected value. So, this value we can select. So, that completes first part. Now, in second part, you can see that they have mentioned that in the second part, the setting range of instantaneous high set unit is given, and the high set instantaneous unit, that should operate at 6500 ampere. So, if I consider the 6500 ampere with this current, we have to find out what is the setting of instantaneous high set unit. So, if I just calculate the instantaneous high set unit, then the instantaneous high set unit, the current given, that is 6500 ampere. So, if I divide this 6500 ampere with the CT ratio, that is 500 by 1, then I think this comes out to be roughly around 13. So, if I consider in percentage, that comes out to be 1300 percentage, and this is of 1 ampere. So, setting range of this instantaneous high set unit, that we can decide as 1300 percentage of 1 ampere. So, this is also completed. So, this completes the second case of the given example. So, we have solved the both the examples, and in first example we have calculated the time of operation of relay, and in the second example we have calculated the time dial setting of the IDMT overcurrent relay. So, with this background, now let us move further. Now, we know that let us see what is the discrimination philosophy of the overcurrent relay. So, basically the discrimination philosophy of overcurrent relay, that is given by 3 different philosophies. The first is known as, it is based on current. So, that is known as current discrimination of the relay. So, what we do is, we have multiple of relays are given and we decide the settings of relay based on current. So, current is the coordinating criteria for in this type of philosophy. The second type of philosophy, that is known as the time discrimination philosophy, and here we use time as the coordinating criteria, and the relay we use, that is definite time overcurrent relay. The third type of criteria, that is the mixture of the first and second, that is current time discrimination, and in this case we will use both current and time as the coordinating feature, and then we decide the settings of the different relays. And the relays we use in this case, that is the first is the inverse time overcurrent relay, and the second we use the IDMT overcurrent relay. Now, in in distribution network, most of the utilities they use only the IDMT overcurrent relay. So, for all our cases we will consider, when we solve the example, we consider all the relays are IDMT overcurrent relays. Now, let us consider each and every philosophy one by one. So, if I use all the 3 relays or 4 relays or multiple relays available in radial structure or radial network, then let us assume that these relays are instantaneous overcurrent relays. So, let us assume that there are 3 relays given. So, if I assume there is a source and then we have a radial structure network, and if I assume that between bus A and B there is a one section, line section or distribution feeder connected, and the relay here, let us say this is R1. Same way between bus C and B and C, the another relay R2 is connected, and same way between bus C and D, the other third relay, let us say R3, that is connected. So, if I consider that this is the feeder section 1, this is the feeder section 2, and this is the feeder section 3. So, in all the 3 sections we have connected 3 different relays, and when we are talking about this relay R1, relay R2 and relay RT, of course the load that is connected at this point. So, when we have a load on one side and source on other side, then we want to decide how this relay coordination of relay R3, R2 and R1 that has to be carried out. So, for this case, let us assume that all the 3 relays R1, R2, R3 are instantaneous overcurrent relays, and this relay operates for fault within its own section. That means, if I consider these 3 line sections, if any fault occurs in section 2, let us say F2, then the relay R2 has to operate, other 2 relays R1 and R3 they do not operate. If any fault occurs in say let us say section 3, say F3, then relay R3 has to operate as a primary relay, other 2 relays R1 and R2 they do not operate. Same way, if any fault occurs in line section 1, say F1, then relay R1 has to operate, other 2 relays R2 and R3 both should not operate, because if they operate, then that is against the requirement of selectivity criteria of the protection system. So, with this background, let us consider the relay R1, R2, R3 are all three are instantaneous overcurrent relays. It may possible that, let us say, if fault occurs in section 2 at F2, relay R2 has to operate as a primary relay, but because of some reason if R2 fails, then R1 has to provide backup. So, backup protection, that is also required when any primary defense system fails, then it is very important. So, with this background, all these three relays are instantaneous overcurrent relays and they are adjusted to operate progressively in the order from the, let us say, the load to source. So, what we the meaning is that if any fault occurs here, then the first relay has to operate, that is relay R3. So, we have to coordinate relay R3 with relay R2 because relay R2 will operate after the operation of relay R3. Similarly, relay R1 will operate after the operation of relay R2 and relay R3. So, as we move from load to source, so we have to set the first relay which is connected near the load, we have to set first. So, setting of relay R3, that has to be decided first, and then as we move further from towards source side, then progressively we have to decide the setting of other relays, say R2, R1 and so on. So, with this background, if I consider the same system as I have drawn, then the relay R1, R2, R3 all are instantaneous overcurrent relays. So, if I want to decide the setting of this relays, then as I told you earlier that instantaneous overcurrent relays, they have only the current setting, they do not have the any time dial setting. So, if this is the case, then what we have to do is, and as I also told you that we have to set the relay which is connected near the load, the setting of the that relay, in this case R3, that has to be decided first. So, the pickup of relay R3 or plug setting of relay R3, that is minimum, and as we move further towards the source from say R2, R1, the pickup of that relay goes on increasing. So, as we move from load to source, the pickup of relay that increases progressively. So, as if I just draw this bus 1 line below, bus 2 line below, bus 3 line below, bus 4 line, if I extend this line, then this indicates the bus number. So, this is your bus number 1, this is your bus number 2, this is your bus number 3 and this is your bus number 4. So, the pickup of this relay R1, R2, R3, that is given like this. So, the pickup of relay R1, that is highest, and pickup of relay R3, that is the lowest one. So, with this background, if I move, then this instantaneous overcurrent relay has certain advantages and disadvantages. Let us discuss first what are the advantages of instantaneous overcurrent relay. So, the first advantage is setting of this relays are independent of the load, that is one thing. That means you can if I just consider the 3 sections, you can carry out the setting independently. So, each relay will operate instantaneously. The second advantage of the instantaneous overcurrent relay, that is they operate instantaneously for all the line sections. So, that means if any fault occurs in say section 3 at F3, R3 operates instantaneously. Similarly, any fault occurs in section 1 say at F1, R1 operates instantaneously. So, this is the all two are the advantages of instantaneous overcurrent relay. Now, let us consider the what are the disadvantages of instantaneous overcurrent relays. So, the first disadvantage is it is not possible to achieve backup protection. So, that what is the meaning? That means if fault occurs at in section 3 say at F3, R3 has to operate as a primary relay and it operates instantaneously. But due to some reason if R3 fails to operate as a primary relay, then R2 has to provide backup. So, this type of backup protection is not possible if I use all the 3 relay R1, R2, R3 all are instantaneous overcurrent relays, because each relay operates instantaneously and it has only one setting, that is current setting, it does not have any time dial setting. So, that is the first disadvantage of instantaneous overcurrent relays. The second disadvantage is instantaneous overcurrent relays are affected by the ratio known as source impedance to the load impedance. So, now let us see what is the load impedance and source impedance. So, ZS by ZL. So, ZS is known as the source impedance. So, source impedance is the impedance from source point to the relaying point. So, this is the impedance between source to the relaying point. So, this is the source impedance ZS. So, if I consider the relay R2, then for relay R2 the source impedance ZS for relay R2, that is up to this point, right, up to substation B. What is load impedance? ZL, that is known as the load impedance, and it is the impedance from relaying point to the fault point. So, from relaying point to the fault point, that impedance is known as the load impedance. So, if I consider fault F2, then for relay R2 the ZL, that is like this. So, we are talking about this ZS by ZL ratio. Now, if I consider R1, R2, R3 all are instantaneous overcurrent relays, then we can say that the ZS by ZL ratio varies depending upon the location of relay. So, ZS depends on location of relay and the ZL depends on the location of fault, at what location fault occurs, accordingly ZL varies. So, as the relay instantaneous overcurrent relay depends on current principle, current discrimination philosophy, and as current is directly associated with this ratio of impedance. So, as this ratio changes, the current value also changes, and that is also going to affect the operation of instantaneous overcurrent relay. So, what is the effect? If I consider, suppose the remote end fault somewhere here at point 1 in line section 1, and if I consider a very close in fault in line section 2, say at number 2, then if I consider relay R1, then due to the effect of this ZS by ZL ratio, relay R1 is not able to provide effective discrimination between remote end fault in section 1, that is at point 1 as shown in figure, and the close in fault in the section 2, that is the fault at point 2. So, it is not possible to discriminate between the remote end fault in one section and close in fault in other section. So, this is the main disadvantage of instantaneous overcurrent relays, that they are affected by the ZS by ZL ratio, that is source impedance to the load impedance ratio. So, this is one of the biggest disadvantage of instantaneous overcurrent relays. Let us discuss the third disadvantage. What is the third disadvantage of instantaneous overcurrent relays? So, the third disadvantage is this relay, all these instantaneous overcurrent relays suffer from the problem of transient overreach. So, now let us discuss what is the transient overreach phenomena. So, transient overreach is defined as, it is the tendency of relay to operate instantaneously beyond its own zone of protection. So, let us see what is the meaning of the instantaneous transient overreach phenomena. So, if I consider the same section, let us say we have the 3 line sections and we have the relay, same relay R1, R2 and R3, that is connected in 3 line sections. Now, if I consider, say for example, that fault occurs in line section 2, very close in fault occurs in line section 2 here, then it may possible that the relay R1 which is located in line section 1, this relay may operate. So, this is against the selectivity criteria of the protection, because fault is in section 2. So, relay R2 has to operate instantaneously as a primary relay and R1 should not operate. But in this case, by mistake, if fault occurs in section 2, very close in fault, and if relay R1 operates, then this type of phenomena, that is known as the transient overreach phenomena. Transient overreach phenomena. So, transient overreach phenomena is defined as, it is the tendency of relay to operate instantaneously beyond its zone of protection. So, here the zone of protection of relay R1 is only up to section 1, whereas fault occurs in section 2. So, this fault at 2, that is the beyond the zone of section of relay R1, then also relay R1 operates. So, that is known as transient overreaching of relay R1. So, Now, how the transient overreach affects, how it comes in picture. So, that we will discuss later on. So, in this class we have discussed, we started our discussion with 2 numericals on overcurrent relay, and then we have discussed the, if I applied the instantaneous overcurrent relays in the radial section or network, then how the what is the behavior of this instantaneous overcurrent relays, what are the advantages and disadvantages of instantaneous overcurrent relays. This transient overreaching phenomena we will discuss later on in the next class. Thank you.